Hello, welcome to this short presentation. My name is Odije Anthony Jr. I'm going to be giving a short presentation on a project that I did in fulfillment of my master's degree in data science here at Leeds Beckett University. So my project was essentially to build a predictive model for Leeds housing market to be able to predict um, to some certain level of accuracy how the price of a house, say in a year's time or in 6 months' time, and to also examine what properties and what features of a house determines the how high the price of a house is going to be, and then be integrating that model with a UI application so that you can interact with it. So the whole idea behind this project is because we see a lot of students coming in, we see a lot of people trying to decide between, should you rent a house, should you buy a house, or should you get a mortgage instead. But the fluctuating rate of prices makes people uncertain. So by building a predictive model, it leads you to give you some sense of um, certainty, or give you an idea of how, let's say, a duplex or a flat is going to be in, say, next year, or say May next year, for example, right? So it will help you make better decisions, essentially. The objective was to find a data set, examine what other researchers have done on this topic, um, understand the data set, understand the features that determine the fluctuations in prices, and use the understanding to try to build a model and try to extract those features and use it to build a model, and then integrate that model with, like I said, a web application. So when I performed an extensive literature review to see what has been done in the past, I found that there were a lot of people have performed similar projects, but none really in Leeds. And another thing I found was that most of the data set were already refined, most of the data set were already transformed and cleaned. The one really ideal or unique thing I should say about this data set was that it's from 1996 down to January of this year. So it's a data that's alive, right? So if we do get a good prediction, we can apply it real world. We can apply it in real time. I found that to be fascinating. So there have been several models or several machine learning algorithms that have been proposed or that have been used. Before, they were just using one, maybe regression model or linear model or statistical analysis, and then moving into random forest and artificial neural network. Recently, what they do is they combine algorithms, they combine models just to see if it will perform. And I actually took the same route. So I decided to examine three models: linear regression, random forest, and gradient boosting, see the best performing models, and then see if I can combine that to get a great better score. Overall, I did achieve that. I was able to get a good estimate of 75% R squared. So the model performed good, performed really well. And then using Flask and Python, I was able to integrate that with a web application. And the methodology I employed for that was the TDSP, because that essentially combines agile methodology and some very popular machine learning methodologies. So since I'm building a software application with data analysis and data science, it just makes sense to use the model. So without further ado, let's go into the uh, the process. So the first process was to, again, get the data, understand the data set, to try to find null values, to try to understand what the data types are, just to eyeball the data to sort of do a preliminary analysis on the data to understand what columns we're probably going to drop, what columns we're probably not going to need, things of that nature. So by just looking at this, I can see that ID is just used as an identifier, probably not important. And I can also see that because we're interested in Leeds, and I can see Harrogate, so and I can see these two records. They're just guess, right? You're thinking, I'm just thinking they're probably not going to be relevant. So next I check for null values to see how many null values, and I was surprised to find out that there were massive amounts of null values. So then the question was, do I take the mean of that score and then replace them with the null values? Or do I just add arbitrary values or just drop the column altogether? It made sense to drop the column because I feel if you add arbitrary values to your data set, you kind of skew it in some way. You kind of bias it in some way. So it's just better to eliminate them, I found. So I also checked for a negative values in the price and just did a general statistics on a target variable, which is the price, getting the minimum value and maximum value for them as well. So the next thing was to perform outlier checks to see where the outliers are, right? So we need a normal distribution. We don't need the data to be skewed in one way or the other. So I checked for that as well, and I found that there's lots of presence of outliers, like as you can see a subsection here. And you can see it's heavily skewed to the right as well, so it's leaning towards the left, which is going to bias the test in the sense that we're going to be getting more lower values, and we don't want that. We want a normal distribution. And then I performed analysis on the categorical variables. Those are the non-numerical variables, non-numerical columns, to see how we're going to convert them to numerical values. So then the cleaning process starts. I only extract data from Leeds that I need. Then I drop the null values as I estimated before. And then I removed all those irrelevant columns. ID is not needed. Town, because it all says Leeds. District, it all says Leeds. Category, and those are just used for like indexing. So they're really not going to be relevant in our evaluation. I removed duplicate rows if there were any, and then I finally dropped the outliers. And after dropping the outliers, you can see now that the box plot is showing. Box plot wasn't even showing before because of how heavily saturated it was with outliers. It was incredible. You had like close to 50 million, and then you're having most of the data around 10,000 to 200,000. So we had to eliminate those. Then transforming the date variable was done because we're going to be performing checks on year and month, and so we need numerical values for that. And some more exploratory data analysis just to see the distribution. And then we transform the categorical values like the property type, the old and new, and the duration. We do that using one hot encoding because they didn't have they just had a finite amount of set values. So it was either detached, it was either flat, it was either terrace, or semi-detached. So it's easy to just increase the dimensionality based on those figures. And after applying log transformation to the price, we were able to reduce the skewness. As you can see, it's now evenly distributed. Log transformation was chosen because most in financial data, when you're dealing with financial data, it's through the literature it's advised that you use log transformation. And then we just go through finding the relevant values, or finding the relevant features. Price is left there just as a baseline, right? So you can see there is a linear correlation with year and not much else, as you can see here with the correlation matrix. It's heavily correlated with year, it's heavily correlated with month, and the property data type as well. And then we move to model selection. So we split the data into test and training sets, and I evaluate the linear regression model first. And as you can see, it didn't really perform well, as the R squared is like 0.48, and most literature say that you need at least 0.6 or 0.65 to have anything close to a good model. So the next test was on random forest, which did well, really well, zero point 0.7 with our data set. And with with mean square error, RMSE and MAE, or mean absolute errors, you're looking for really small values, right? So the smaller the value, the better your model is performing. And then finally, gradient boosting. And you can see this also performs well. So now that I have my two performing models, I just did cross validation on the models to evaluate them, and I still essentially get the same values. So next was to build the model itself, down to the model itself. So train the data with the random forest, right? Get the residuals, that's the errors. Train the errors with the gradient boosting, get the predictors and combine both of them and see if we get any improved value, which we did. We get 7.4, which is approximately 7.5. And that's a really good model performance. So after that, next thing was to integrate this with a web application, which I have done here. Now, this process, as you can see, it's really, really intuitive. It's easy to use. You can come here and select the property type that you're interested in. You want to know how much how much a new flat is going to cost me, say next year, maybe in October next year, and you click on predict. This process takes approximately 4 minutes to execute, so I don't really have the time, but essentially when it's done, you get the predicted price displayed here. The reason it takes that long, again, is due to the limitation of my hardware, and I think also what's going to help would be to export the already normalized data. I'll say the major limitation I faced during this entire process was gathering of data. I really wanted to explore data sets that had number of bedrooms, number of bathrooms, and combine that with this, but I couldn't find. But I wasn't. But not to say that this data set was not good. It was really good because whatever value or the information we get now, we can actually apply it to real life, and we can apply it here in Leeds. And with this, I come to the end of my presentation. I hope this was informative, and I will leave a link to this presentation on my poster. So thank you once again. My name is Odiji Anthony Jr. Thanks for watching.